All right. So here's what we're going to do. I want to just cover some of the theory behind trig so that you understand what it is that we're going to be doing um, this evening, and so that when you get your assignments, that the assignment is clear for you, that there's no concerns. The objectives for this lesson and next week's lesson is to be able to identify the sides of a right triangle with reference to any angle, which I'll explain in a moment. Be able to state the ratios of the 6 trigonometric functions in relation to the given triangles, which we're going to demonstrate. And then over the next couple of weeks, find functions of angles given in decimal degrees and degrees, minutes, seconds, and then find angles in decimal degrees and degrees, minutes, and seconds. So trig, for some of you, it may be a scary topic. For others, you might be excited about it. But really, trigonometry, all it is, it's the branch of mathematics that we use to compute unknown angles and unknown sides of triangles. And many instructors over the years, all of the math is the same, but how it's explained, I think, makes a big difference. Probably the reason why I hated trig in high school. I found it very difficult to follow. So we try to break it down into some very simple, easy to understand lessons. So the first thing, I don't know if you guys can look at your lesson plan while I'm doing our lesson, but if you ever can, it's probably a good idea because it'll help you kind of grasp the concepts. And if a question comes up, or if there's something that you want to ask a question on, you have the information in front of you. So I'm just going to read the definition, or read this statement right off your lesson plan. So we got a right angle here on the screen for you to look at. In a right angle triangle, the ratio, we talked about ratios, okay? We all know what a ratio is. The ratio of two sides of the triangle determines the sizes of the angles. And the angles determine the ratio of two sides. So what's interesting about this is there is a direct relationship between the size of an angle and the length of a side or sides. So for example, the example that I gave you guys on your lesson plan kind of looks like this. Can you hear me okay?
Yeah.
Okay. So it kind of looks like this. A equals 2 and B equals 2. Okay. So in this case, we're going to talk about this angle. And one thing I want to explain right from the beginning, okay, that explanation about the ratio of two sides of a triangle determines the size of an angle. And an angle determines the ratio of the sides. So that tells us right away that we need to be talking about a definite angle. Okay, so it's not just some random angle. Any angle that we are trying to solve, or any angle that we are using in a formula, that is the angle that determines how we read a triangle. And I'm going to go into a little bit more detail about that in just a minute. So we're going to talk about angle A here for a moment. Okay, so this is angle A in here. Because this is the angle that we are talking about, it directly is influenced and can influence this side and this side. You don't have to worry about the hypotenuse. Okay, we'll talk about that later. But angle A, okay, which is this one here, angle A has a direct relationship with this side and with this side, and these sides have a relationship with this angle, but it's all about ratio. So imagine this for a second. If we write this formula, right, to the ratio of A to B, is 2 to 2, right? Because A equals 2 and B equals 2. So the ratio of this side opposite of the angle and this side, which is adjacent to the angle, the ratio is 2 to 2, which we learned about reducing is 1 to 1. Okay, so clear. That's easy, 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 right? However, if the triangle, if I draw a new line, let's say here, this becomes my new triangle. Okay, now the height, of this triangle, A, equals 1. Okay, so let's say I split this in half and I draw a line right at the midpoint and then back to the vertex. A, now this height now equals 1, which changes my ratio. My ratio is now 1 to 2, which equals a half, right? 0.5. Okay, so what does that mean? Well, if you notice here, the angle A, when this side was 2 inches tall, the angle was this. You hear me okay?
Yeah, you're back.
Okay. The angle was this red arrow. Now angle A is here. Now this is angle A, right? In here. Because what's happened is the opposite side has got shorter, which carries this point down, right? So that point comes down, which makes this angle more shallow. So you can see the relationship. A side has a direct relationship to its opposite angle, right? And we could imagine then this angle here, right? This angle will change as this length changes, right? So if this length shortens, the angle up here is going to change, right? So we need to understand how the sides have a bearing on the triangles. So what we'll do is I'll give you a couple of things to think about here. I'm not sure why this is slowing down so much, but are you guys seeing any lag on my side? Are you okay?
It comes in waves. Like sometimes you're okay, sometimes it's really
Okay.
choppy,
All
and
right.
sometimes you just cut out completely.
All right. Well, hopefully this will sort itself out real quick. Nice thing is when I post this on YouTube, you'll have everything. Okay, so what we then can determine from all of this information is that an angle and its sides have a very specific relationship. Okay, this is the basis of trig right here. Okay, so angle A is always directly opposite side A. Angle B is always directly opposite side B. And the hypotenuse is always directly opposite the right angle, right? Because we're talking about right angle triangles. This doesn't change, okay? Angle A is always opposite side A. Angle B, always opposite side B. And the hypotenuse is always opposite the right angle. Now this helps us because when we go to solve unknown angles of triangle sides of triangles, or unknown angles, sorry, of triangles, or unknown sides of triangles, when we go to do this, we have to fill in the algebraic expression with the unknown or with the known information. So we can only fill that in if we understand what belongs in that equation. We talked a little bit about that last week when we had our algebra lesson. So what we need to do is be able to take this information and determine, let's say for instance, how to solve something that's missing. But this relationship is what tells us how to do that. So let's bring in another triangle here for a second, and I'm just going to draw a right angle triangle. All right. And I'm going to say that this here is angle A. Actually, you know what we'll do? We'll do this. We'll go, oops. We'll say that this angle is 35 degrees. And we're going to say that this hypotenuse, let's see, yeah, we'll say the hypotenuse is 12 inches long from here to here. Now, the first thing about trigonometry that is really important to understand when trying to solve unknown information is that to solve any missing information, you already have to know at least 2 angles and 1 side, or you have to know 2 sides and 1 angle. Okay? So in this example up here at the top, we know 1 angle, we know 2 angles, because this is 90, and we know the length of a side. So then in theory, we should be able to solve this angle if we need to. We should be able to solve this length, and we should be able to solve this height based on the rules of trig. So I'm going to bump over to another slide here. Okay. So here's where we start. How many of you remember this? Remember this from high school?
I remember it.
Yeah.
Yeah.
Do you remember what it means?
Sine, opposite height, cosine, or not, is it height?
Hypotenuse.
Hypotenuse.
Hypotenuse, yeah.
Yeah.
Cosine, adjacent hypotenuse, and tangent, opposite, adjacent.
Correct. So really, this is just a short form of this. So
Yeah, I ain't never seen that before.
you've never, or you have?
Nah, man.
Okay.
Yeah, that's like an alien lettering to me.
All right. So we
I don't remember that.
we refer to this as Socatoa. All right. That's what it is. Socatoa.
Okay.
All right. So this, I promise you, this is a lot easier than it looks. What this is I'm gonna draw just a triangle here to refer to as we're talking. Okay. Socatoa is a way of remembering. It's an acronym to remember how the formulas in trig work. So here's how they work. The first 3 letters, S-O-H. And it looks like I have an unstable connection. So if I drop out, just let me know when I come back. So SOH means this: sine of an angle equals the opposite side divided by the hypotenuse. Now, this isn't complex because we just talked about a minute ago that an angle is directly proportionate to the ratio of 2 sides. And this is what we have. Remember, a ratio is simply dividing. So all we have to remember is which sides control an angle. So and we'll talk about what sine, cosine, and tangent is in a minute. But as long as you can remember this acronym, Socatoa, sine of an angle equals opposite over hypotenuse. Cosine of an angle equals the adjacent over hypotenuse. And tangent of an angle equals opposite over adjacent. So in a practical, yeah, go ahead.
You cut out
damn.
as you start talking about cosine there.
Okay,
Oh, what done when you were gone?
sorry. So sine of the angle equals opposite over hypotenuse. Cosine of an angle equals adjacent over hypotenuse, and tangent of an angle equals opposite over adjacent. So let's observe this in a practical part here, a practical setting. So I'm going to say that this angle down here is 20 degrees. All right. So right away, I'm determining an angle. Bang, bang, bang. Right? Whatever angle I'm talking about or whatever angle I'm trying to solve, okay, is represented here. Angle. There's only one angle call out. So we can only ever be talking about one angle. All right. So is it the sine of an angle? Is it the cosine of an angle? Or is it the tangent of an angle? How would we ever know? Well, these ratios tell us which formula we use by the information that's given to us on the triangle. So if I go back to this example, this is a 12-inch length, and I want to solve A. I want to know the distance from here to here because I'm setting up a machine and I need to run a tool path and create up a keyway that's exactly A long. Okay, so the print says you need to start here and end here, but you don't know how long to program that toolpath. So we need to figure out what this length is. So how we do that is we look at what this triangle is telling us. So number one, we have an angle. So right now we could pick any three of these formulas because they all have an angle. But what else do we know about this triangle? Well, we know the hypotenuse. So we need to look over here at a formula that has hypotenuse in it. So sine has hypotenuse and cosine has hypotenuse. So now we know that tangent is not the trig function we're going to use because it does not have hypotenuse in its formula. What are we trying to solve? We're trying to solve A. But what is A? Is A opposite or is it adjacent? This goes back to the rule about angles. An angle is directly proportionate to the ratio of two sides. So that means that this angle is controlled by a side. And we know that if I lengthen this line or shorten it, this angle changes. So for me to solve A, I need to know what its position is. Well, it's opposite the 20 degrees. This B here is adjacent. Adjacent means a side touching or running along, right? This side is not touching or running along this angle. It is opposite the angle. So I'm looking for a formula that has a hypotenuse and has an opposite side to an angle, and that's sine. It has opposite and it has hypotenuse. So I know that I don't need cosine. So I've determined that the algebraic expression or the trig function I want to use is sine 20 degrees equals A over 12. So the lesson on algebra last week helps us, first of all, remember we had those A equals 5, B equals 3, etc., etc. So until we know the values, I mean, this literal number has a value, we just don't know it yet. So we use it as a placeholder, right? So what we have to do at this point is we have to solve for the unknown, okay? So we'll get into the solving part in just a second. I want to move our sheet over for a sec. So let's go to before we start solving triangles, let's go to another example here. I'm actually just going to grab this triangle here, make life easy. Copy and paste. Okay. So let's say for a moment that we have a 32-degree angle here, and we have let's see, we have a 15-inch length here, and I want to solve this height. So maybe if we're connected strongly here, maybe somebody could tell me what trig function, Socatoa, okay, which trig function has this side in it and this side in relation to this angle. So maybe someone could tell me what this side is called based on this angle. What would be the name of this side?
I don't think anyone can see which side you're pointing to.
Oh, I'm sorry. This side. This side is called what?
That would be the opposite side.
Okay, so this is our opposite. Thanks for letting me know that. And what is this side called then?
Adjacent.
It is the adjacent. Okay, so which trig formula has opposite and adjacent according to our acronym here?
Tangent.
It does. So tangent of 32 degrees equals opposite, which we know has a value of 15, and an unknown value of b. So the first step in trig is to, what is it you need to solve, and then which trig function do you use to solve the missing information. Okay, we'll do one more example here. So let's grab this triangle again, paste, and we'll do this. Okay, so let's say that we know this is a right angle triangle. We know that this is, let's say, 107 millimeters long, and this is let's say 90 millimeters long, and I want to know this angle. So based on our acronym Socatoa, maybe someone else could take a stab at this. If I want to solve this angle, which trig function do I use here? So what is this side called?
Hypotenuse.
It is. So Levi, that tells us we have two choices so far. Which two choices do we have based on
Sine and cosine.
sine and cosine? All right. And this side here is called what then, Levi? According to the angle.
I'm guessing adjacent.
It is adjacent because it is the side that is running along or touching this angle, right? So if it's adjacent and hypotenuse, that tells us cosine, right? But here's the difference. Cosine of the angle, because we don't know it, equals the adjacent, which is 90, over the hypotenuse, which is 107. Okay, so what I'm going to do is I'm going to go back through these three, and we're going to solve them, and I'm going to remind you of how we rewrite formulas so that we're isolating the unknown. So I'm just going to drag back our screen here for a sec. So let's go to this example here. Okay, so in this first example, we determined that this side A, which we want to solve, is opposite to the 20 degrees. So because this angle is given to us and this length of hypotenuse is given to us, we can solve A, because the sine of 20 equals the ratio of the opposite side divided by, right, the opposite side divided by the hypotenuse, which we have here. So to rewrite this then, we need to isolate the A, or the opposite side. So we do that by remembering this rule. I'm just going to pull down here. Okay, so here's the rule. So sine 20 equals A over 12. Remember that anytime you have a whole number, and in this case sine 20 represents a number, right? Anytime you have a number, it's written over a 1. There's only one sine of 20. So we've turned, remember we talked about how important ratios and proportions are? So now we've turned a ratio into a proportion. We're saying sine of 20 over 1 is the same as A over 12. So the proper way to do this is to cross multiply, right? So 1 times A is 1A. You don't have to write the 1, okay, because 1A is 1A, and there it is. 1 times A is A. Sine 20 times 12 is sine 20, and we learned in algebra that we use brackets for multiplication. So that's how we move the A and isolate it. I notice I have an unstable connection. Are we okay?
Yeah, you're good now.
We're good now? Okay. Okay, so we've isolated the A. So now all we have to do is solve this. Now, everybody should have a scientific calculator. Okay, now I know some of you use your phones and the computer calculator, but make sure it has the trig functions on it, sine, cosine, and tangent. So you actually enter this just like you wrote it. So on your calculator, you hit the SIN, which is sine. I don't know, I gotta just get the glare off. So SIN, okay, for me it's up here. Sine, and then you just type 20, okay, sine 20, and then times 12 equals. And you should get a number, oops, sorry, I'm mirror image. You should get a number something like that, 4.104244172. So I would then, in this case, I didn't give you guys a decimal place to round to. So I'm going to round to whole numbers because the hypotenuse is 12. So 4.104 rounds to 4 inch. So therefore A equals 4. And we could solve B as well with trig, or since we have two sides of a right angle triangle, we could use the Pythagorean theorem, right? A squared plus B squared equals C squared. Let's just move over to our second example here. So in this example, we determined, so this is the angle we're talking about, right? This is the angle we're talking about. This is its opposite side because it's opposite that angle. And this is its adjacent side because it's the side that runs along the angle or touches, right, at the vertex. So tan of 32 degrees equals 15 divided by B. So how do we rewrite this formula? Same exact way. Tan 32 over 1 equals 15 over B. So remember, this is only one tan of 32, so you can write it over a 1. And then we cross multiply. 1 times 15 is 15. 15 equals tan 32 times B. Now, we don't, we actually don't need to do this step, but I'm going to show you how it breaks down because we can do that right up here at the very beginning. But I want to show you how the cross multiplying changes when your unknown information is your denominator. In our previous example, the unknown information was our numerator. So to simplify this equation, like if you ever, when you started using trig all the time, you remember how things move really quick. So if you can remember that if your unknown information is at the top, is the numerator, then you simply just have to multiply sine 20 by 12. Sine 20 times 12 will give you your answer. Okay. If your unknown information is your denominator, which I'm going to show you a simple solution up here in a second, then these are the steps. The longhand way of doing this, right? So 15 equals tan 32 times b. Remember, if you want to move something to the other side of an equal sign, you have to do the opposite of what it currently is asking for. So right now, I have to multiply the tangent of 32 times b to get an answer. But if I want to move this tangent 32 over here, I have to do the opposite of multiplying. I have to divide it by the tan of 32. So we talked about this in algebra the other day. Anytime you multiply something and then divide by the exact same thing, why did you do it in the first place, right? These two cancel each other out. But whatever you do on this side, you have to do on this side as well. So if I divide this side by tan of 32, I have to divide this side by tan of 32. Okay? Because that's what makes this equal sign true. Whatever you do to this side, you have to do to this side. It's the only way that this stays true. Okay, so now these two cancel each other out, and we rewrite this, just to keep it simple, as 15 over tan 32 equals b. Okay, so let's go really simple now. Let's go up to the top here. Back here for one sec. Oops, sorry. Okay, back here for one sec. I said to you, if the unknown information is at the top, then you can simply rewrite this equation like this. When your unknown information is at the top, just rewrite your equation as sine of whatever the angle is times the denominator, and you will get your answer. Okay, done. When the unknown information is the numerator. When the unknown information is the denominator, oops, okay, you can just rewrite it like this. So tan, I moved some things around here, sorry, but you can rewrite it like this. Tan 32, okay, so 15 over tan 32 equals b. So if you look here, we had tan 32 equals 15 over b, and then we started breaking down this formula. If you just simply move the 15 over here, just write it on top, and then leave b by itself, then that's how you would rewrite this formula. You get the same thing down here. See, 15 over tan 32 equals b. So if you know the numerator, just move it over top of tan 32. If you know the denominator, then just multiply it by sine. Okay, and this is just something that comes with practice. Okay, I don't expect that you're going to memorize this right away. That's okay, but just that's a simple way of breaking that down. But what if what we're trying to solve is an angle, which is often the case. A lot of times this is what we're solving for. So how do we actually solve this? Well, we don't know the angle, so therefore we can't finish this trig function.
For about 10 seconds.
Okay, thank you. When we're trying to solve an angle, if you notice, we're trying to solve this information only. But we can't solve the cosine of this angle until we know the angle. And this is where knowing how to use your calculator is very important. So the first part of this is very simple. You simply do the ratio, right? 90 divided by 107, okay? And this, I'll just rewrite it according to what the calculator says. Cosine of the angle equals 0.841121495. So what is this? This is simply a decimal equivalent to the ratio, okay? That's all it is. This is the decimal fraction. This does not tell us the angle. What this is telling us is the cosine of the angle. What we want is the angle. So how do we get the angle? So if you look at my calculator, that's the number that when I entered the ratio, 90 divided by 107, I get 0.841121495. Okay, what I want to do is I want to convert that into an angle. On your calculator, you will have a button that says second function. Usually the top left corner, it'll say 2 NDF, or it may, and on mine it is right there. Okay, right there. Oh, I'm sorry, I'm mirror image, so I'm struggling here. There. Okay, on yours it may say shift. What that does is it allows you to access the secondary menu, the orange functions on your calculator. So while you have this number in your calculator, you want to hit that second function button. And forgive me because I'm really trying to make you guys see this. You hit the second function button, and then you hit the where is it here? What is our trig function? Our trig function is cosine, right? So second function, and then you hit the button COS. And that gives you this number, 32.74126308. So I'm going to write this down. So the next step on your calculator is to hit 2NDF, which is your second function button. And then whatever the trig function you're using, so in this case we're using cosine, so hit this button first and then hit cosine second, and equals, in this case, gives you 74126. All right, so my question is, this number that you just got, do you know what that is? Do you know what this represents? Well, if I put this here, now you know what it represents. This is a decimal degree. In our lesson plan for tonight, I said that we will solve trigonometric functions in decimal degrees and then degrees, minutes, seconds. This is an answer. This is 32.74, etc. degrees. But what if the requirement is whole degrees? What would I round this to for whole degrees?
33.
Yes, I would. I round this to 33 degrees because 7 is greater than 5, right? And that rounds me up to 33 degrees. Okay. So first thing I want to ask you guys is if, because we're going to do a couple more examples here, is if this information so far, does it make sense? Does what I'm showing you make some sense? Is there...
No. I'm lagging worse than your internet right now, man.
Oh, that's okay.
Like my brain, not my internet.
No, that is...
I'll rewatch the video, you know what I'm saying?
Yeah. So what I'm going to do is, let's take note of the time. 43 minutes into the video, what I'm going to do is I'm going to take one triangle, and I'm going to have you guys tell me one at a time the information about the triangle. Okay, so I'm going to ask you the question. So you can go back to this time in the video, about 43.5 minutes. and this will be a good place to review. All right, let's do this. So I'm going to start with Ryan. I'm going to start with you. Okay.
You're getting a lot of cliffhangers with these episodes.
We missed all the instructions. As soon as
Oh, I just told you guys how to.
I'm going to.
Yeah.
And then you're just going.
Oh, I just told you the final answer to the final test for the whole course. It's too bad.
Really?
Too bad.
Just trying to get the YouTube views now. Go back and watch the number.
Okay, so Ryan, what I'm going to get you to do is I'm going to get you to fill in.
Oh God.
Yeah, I'm going to get you to fill in the information on this triangle. Okay.
So, I should have said I got it.
Yeah, but you know what? I'm glad you didn't. Okay, so this is our acronym, right?
All right, it's a triangle.
All
right, I got that right.
Yeah, attaboy. Okay, that's a good start. If you had said anything else, we'd move on to Miles. Okay, so right now, the only thing you know about this triangle is what?
It's got a right angle.
That's it,
yeah.
Right? And here's the thing. If you guys come across a question in basic trigonometry, what we're learning here, and it's not a right angle, you can't do trig, okay? In future math courses, I teach advanced trig, which is oblique triangles. So if you think this is fun, that is exciting. So a right angle, it's all you know right now. Okay, so what I am going to tell you is I'm going to tell you that this angle down here, Ryan, is 33 degrees, okay?
Okay.
And I'm going to tell you that the length of this side is 11 inches. Okay, the length of this side is 11 inches. And what I want to know is I want to know how long this side is. So here's what I want you to tell me. I want you to tell me what this side, the 11-inch side, is called. Now, that's okay. This is why I'm asking. I'm going to break it right down really simple. What is the 11-inch side called according to this triangle? And we're referencing this angle. This is the angle I gave you. So everything about this triangle is based.
It's like it's on the other side.
What's that called? What's this side? What's that side called?
I don't.
No, it's all right. What is it called? So you've got three sides. What sides do you know?
Well, 11 is, and 8 is a side.
Okay, so
and there's the hypotenuse.
Hypotenuse. Okay, so this is your hypotenuse. I haven't asked for any information about this, and I don't want you to solve anything. So right away, you know that you're not going to be dealing with a formula that has hypotenuse in it. So which formulas up here have hypotenuse in it?
SOH and CAH.
Right.
SOCA.
Yeah, right. So sine of the angle and cosine of the angle. Since they both have hypotenuse, then we don't need to use it. What did I just do there? That was funny. Can I undo that? Yeah, I can. Okay, so we don't need those two angles, or those two trig functions, because we don't care about hypotenuse. So that tells us we're going to use which trig function then, right?
I'm guessing the last one.
Which is called what?
Tan or Toa or something.
Tan, yeah. Tan. Tan means tangent.
It looks like.
Yeah, it is because. Okay, I'm glad you said that. Why does it look like? Why does it look like?
I'm just gonna mute my.
No. This is good because it helps me understand how I'm explaining.
I'm not really accepting it like right now. I'm so tired, man.
Okay.
But okay, no, it's good for the lesson. I'll rewatch it.
This is good. This says TOA. Why does it say that? Because it's part of an acronym. The T means tan or tangent. Okay. The O means opposite. And the A means adjacent. So all this means is this just tells us how the formula is made up. So let's take TOA, the part of the acronym we're going to use. It means tangent of an angle equals O divided by A. Opposite divided by adjacent. This formula is always thought of this way. Start with SOHCAH and then break it down even simpler, okay? S equals, this is what the SOH means. S equals O divided by h. C equals A divided by h. And T equals O divided by A, which I always do it this way so it helps me remember when I was first learning trig. The S stands for sine of the angle equals opposite divided by hypotenuse. So this formula, sine of the angle equals opposite divided by hypotenuse, is right here. Sine of the angle equals opposite divided by hypotenuse. Therefore, cosine of C equals A over H is cosine of the angle equals adjacent divided by hypotenuse. And then if we drag this over, T equals O over A means tangent of the angle equals opposite over adjacent. I know, Ryan and everyone else, I know that this is always confusing at the beginning, but here's all we care about right now. The only thing that matters to us is the triangle itself. The triangle is going to tell us, based on what angle we're talking about, the triangle, the information that we're looking for is based on the angle that we're talking about. So I'm gonna get rid of this. I'm gonna get rid of this. We don't need it. Let's not get confused. Okay, who cares about all of this? All right, let's go back to here, Ryan. Here's your right angle triangle. Okay.
Indeed.
In this right angle triangle, the 33 degrees is the angle we're talking about. Okay, so right away you know that whatever trig function you're going to use, sine, cosine, or tangent, it'll be sine of 33 degrees or cosine of 33 degrees or tangent of 33 degrees. This is the angle. But what do I use? Sine, cosine, or tangent? I want to use the formula that has the opposite side in it and it has the adjacent side in it, because one of them we know, one we want to solve. You told me it was tan. So the formula reads tan, or tangent, of 33 degrees equals the opposite side, 11, divided by the unknown side. And I mentioned to you guys earlier that if the known information is on the top, just simply bring it over. So I can rewrite this as 11 over tan 33 equals B. Okay. So let's go back to what it is we're trying to solve. One of the very first lessons I said to you guys when we were talking about geometry was only look for the information that we need, right? And in this case, we just need, I don't care about anything else in this triangle. What I care about is B. I'm trying to solve it. So I have to find a formula that allows me to solve B. And that formula, there's only going to be one of them, right? And you isolated it, Ryan, by saying that this is the hypotenuse.
Is that how that happened? I kind of thought you isolated it.
No, you did. You told me that was a hypotenuse, so I wrote hypotenuse.
Oh, really?
Yeah.
Okay.
Do you know what the hypotenuse is in a triangle, a right angle triangle?
It's the bigger side.
Always. Okay. Hypotenuse is always the longest side. So this side will never change in a triangle. The only sides that swap are these two sides, and here's why. Right now, we're talking about this angle, Ryan, 33 degrees, right? That's the angle we're talking about. So right now, the 11-inch height is the opposite side of the 33 degrees. Okay, that's clear, that's obvious. And the B is the adjacent side. It's the side that runs along or beside the 33 degrees. So that's easy. However, they can swap locations if we talk about the other angle. If I told you that this angle up here is 61 degrees.
Quick question. Doesn't the hypotenuse also run adjacent to the 33 degrees?
Yes, but hypotenuse overrules, right? Hypotenuse is always opposite the right angle. Always. So the hypotenuse can never be adjacent. So that's what I need you to logically sort out. So yes, of course, it's adjacent to the 33 right now, but because it is the longest side of a triangle, it will always be the hypotenuse. That overrules. Okay. So now, Ryan, if I'm talking about this angle, okay, I said to you, Ryan, this is the angle that we're going to be talking about. I want to solve.
61 up there.
Yep. I want to solve B. What is this side?
The B is now opposite, and 11's the adjacent.
That's it. So
Ooh.
if everybody heard that, that's 90% of trig right there. Okay, that's the big piece of this puzzle. The angle determines what the sides are called. So if we're talking about 61 degrees, this is the angle that we're referencing, then this side has to be opposite and this side has to be adjacent. If I'm talking about the 33-degree angle, now this side is opposite and this side is adjacent. The angle tells you what the sides are called. So that is why this acronym, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. That's why this is so important, because the opposite side can change according to the angle we're talking about. So if you understand that whatever the angle is that we're referencing, and in every trig question, there is an angle we're talking about or an angle we're trying to solve. That's the angle that belongs in the equation. There's only ever one. So right away, you know what the angle is that you are using or the angle you're going to solve belongs in the equation. The rest of the information is based on where that angle is. So if the angle's here, this is now the opposite side. Sorry, if the angle's here, this is now the opposite side. If the angle's here, this is now the opposite side. And that's the only two things that change. They swap according to the angle. So I'm going to go reference back down here, right? We determined that the 33-degree angle is the angle we want to talk about. The 11 is the opposite side, and B is the unknown. It's the adjacent. So I need a formula that has opposite and adjacent, which is tangent. So Ryan, if the 61 degree is the angle I'm talking about, and I wanted to, let's say, I'll just drag my screen down here just so you don't have a whole jumble. If you're like me and have attention deficit disorder, that is an absolute nightmare to look at. So here we go, 61 degrees here. And
no attention disorder right now.
That's fair. Okay, and this is 8 inches. And I want to know how long the hypotenuse is. All I want you to do, Ryan, don't worry about the equations. All I want you to do is tell me what the sides are called based on this angle. So what is the 8-inch side called?
Adjacent.
Yes, sir. So 8 inches is the adjacent side. We'll just make a note here just for us. What is this side over here called? We'll call this side
opposite.
Yeah, we'll call it side Y, let's say. So Y is opposite, okay? But guess what? We don't have any information on this side. I didn't even give you a letter, nothing, right? This side is called what? The X is called what?
It disappeared for 10 seconds.
Oh, sorry. So what's the X side called?
Hypotenuse.
Okay, so we need a trig function that has what two pieces of information in it, Ryan? What based on this angle, we need what two pieces of information?
An adjacent and an opposite, right?
So the opposite is over here.
Right.
Yep.
Trying to find the hypotenuse.
Yes, we're trying to find the hypotenuse. So we need a trig function that has what then?
So we need an H then.
Yes.
Is what you're saying?
You got it. Okay, so Socatoa. I tell my students, anytime you're going to write a test, write Socatoa.
I don't think of Croatoan every time I hear that word.
All right. So we need a trig function that has hypotenuse in it, right? You just said, because we're trying to solve the hypotenuse. So we know it's either going to be sine or cosine, right, Ryan? Because they both have an h, right? So
Okay.
what else do we know about the triangle, Ryan?
Well, there's the opposite that doesn't have a number
Okay,
or
so
whatever.
we don't care about that, right? It helps us
Okay,
in
yeah,
no way
okay.
at all.
Sounds good to me.
Yeah. Well, does it help us? We don't see it.
No,
Yeah.
no.
So what?
Just forget about it, yeah.
So what do we know?
Well, the 8. So the adjacent. Yeah, yeah. So
So
it's a call. It's the middle one.
that's right. So
Oh,
cosine of 61 degrees equals the adjacent divided by the unknown. And this is why the first week, the assignment that you guys get will be about looking at a triangle. This is the angle. Tell me what the sides are called. And I gave you a few, because if you grasp that, the rest of this is no problem. We'll be flying through trig like nothing. But you